right. Guess what? It's Tuesday. It's Tech Tuesday. And we're live on IAEI News Live. It is 12 o'clock Eastern, 12:01. We got, oh yeah, man, I'll tell you what. Who do we got? We got Jason Doty, first one up to bat. Tech Tuesday for the win. Yes. And, hey, everybody's doing okay. Maggie. Man, I gotta tell you the story. Maggie is one of our Labradors, and she is seeing some tough times right now. So she needs some prayers. She's we were trying to figure out if she has cancer, and we found another little tumor on her, and all this jazz. So anyway, Jason, thanks for asking and reaching out, and keep Maggie in your prayers, please. But you would never know that dog has anything wrong with her, because she is a ball of energy. She can't go up the stairs anymore. I carry her up the stairs. It's sad, but I do. And she walks over and she holds that little paw up for me, and I put my arm in and around her waist and carry her up the steps. So she just thinks it's a part of life now, and it is, unfortunately. Yummy fudge. Yes, data centers. And I got your email. I forgot to send you a note back. In fact, I love your data center. I am in the process as well. I've got my own little data center going on at the house, but my problem is I got like multiple computers distributed, and I want to get them all into one location. I want to get a rack like the one you have. But we're going to talk about data centers today. Today's topic is data centers, and there's a lot going on in the industry, globally, and from a U.S. perspective, Canada, Mexico, and from just a global perspective. There's a lot going on in data centers. Artificial intelligence, we've all used it. I mean, ChatGPT and all these other resources online it's just phenomenal on our experience and what we can get out of it. But what we don't know and don't realize is all of the stuff that's going on behind the scenes to make that happen. So, Yummy, we are going to talk about data centers, and we got the one and only David Engelhardt. So I mentioned you this morning on my little advertisement clip. Have you ever done a plan review on a data center? I would love to know. I know you're big on plan reviews, and you're good at what you do, so it'd be interesting to hear your feedback on this topic. You love data. I love it. I love this stuff. Man, I'll tell you what. I should show everybody your data center. But you mentioned in your thing it's kind of messy, so I know some people don't like to show the mess. But anyway, thanks for sharing your stuff with me. And we're gonna talk. I probably will need your consult. We got Laurel from Omaha. Thanks for joining in. Dawn Ganir. Dawn, you have to tell me if I am saying your name incorrectly. I had a discussion with someone else, and they were like, "No, it's not Ganir." And he gave me a different pronunciation. And you know what that's like? It's like I have another close friend of mine who's I have apparently been mispronouncing his last name for decades. So Russ's last name is Safreed. And I always said, this is Russ Safreed. And that's the way I pronounced it. And I would introduce him that way to people at IEEE events and things like that. Then one day we were going live together, and there's a program. Right before we went live, I mean, we were seconds away from hitting the go button, and he said, "Oh, hey, Tom, by the way, my last name, it's Safreed." How many years have I known you? Dawn, you and I are going to have to talk next time I see you. Hey, thank you, Jason. Thank you very much. Thank you very much. Yes, sad puppy. She's a good girl, though. Joe Ballard, good to see you, buddy. Yes, and there is so much going. I am saying it correct. God bless you. Then they're saying it wrong. Love it. All right, so there is a lot going on behind the scenes, and we as whether you're a designer, an installer, an inspector, a maintainer, I think a good comprehensive review of all the codes and standards around data centers is very healthy and very important to make sure that we don't, how did you say, miss something, okay? So, see, I'm going to put this on record. Dawn Ganir says I am saying it correctly. Thank you. Hofkin in the house. And you know, Michael, I'm going to have to travel with that, it's no longer, oh man, what is it called? What is it called? What's product IQ? I got to put that behind me, and that sign. So David Engelhardt says he hasn't done many, but Article 645 comes to mind, and it comes to my mind too. And there's a few other ones, David. There's a few other areas, and we're going to get into that here in unos momentos, señor. And I can't. Where is my notepad? Oh, there it is, right there. I was walking over it. All right. Felix, ¿cómo está? Muy bien. Mucho gusto, Mr. Felix Sandoval. Thank you for being here. Gracias. All right, Yummy Fudge. Many dozens or 100 plus megawatts swapping power in that's exactly right, to get the backup power online under 20 seconds. All right, so here we go. All right, data centers. If you think about what is a data center, when I looked at the National Electrical Code, if I look at NEC, I gotta bring up and hopefully everybody out there has NFPA link. When I look at the NEC, see if this works. Yes. All right. The NEC is laid out this way. The National Electrical Code is laid out as general requirements. We know that would apply because it applies generally. It applies to all applications. General requirements are going to be a part of our discussion. Wiring and protection. The last time I checked, there are wires in data centers. That's going to be a part of our discussion. Chapter 3, wiring methods. One of the big wiring methods that I have seen employed in data centers is, you know what, and I don't even know, is it a chapter 3? Where is busway? There it is, 368, busway. This article is prominent in, and let's take a look at the scope. Article covers service entrance, feeder, and branch circuit busways and associated fittings. It doesn't say anything specifically about data centers, but we see busway in data centers every day of the week, and twice on Sunday. All right. Why do we see busway in data centers? Because it is flexible. I can move my equipment around. You might say, well, Tom, data center's pretty jam-packed. You don't move stuff around. Maybe not, but if you need another power tap, you can get that very easily from busway, where it might not be as readily available as with other standard wiring methods when you hardwire and you junction boxes and things like that. So busway, and remember what I always say busway is, so here's my busway. Busway is a highly efficient fault delivering system. Busway can present a very low impedance. We see busway in high-rise buildings, just to give you another example. And one of the things that I've seen in larger cities where you have 200,000 amps available at the bottom of that structure. And then you have busway that delivers power up through the structure all the way up to the top floor. That top floor is going to have a lot of fault current. And where do we put, what do we put up there? I don't know. Maybe HVAC equipment? Maybe elevator control panels? Do I have to think about SCCR? Abso-freaking-lutely. So, hey, Eric Hammond in the house. Way to go, Idaho. Welcome to the session. Yes, I'm sporting my Mark Odie gave me this pin for the Marines. So I got my U.S. flag going on, and then I got my IEEE Electrical Safety Workshop chair pin. I chaired this event one time. We all sort of take our turns. Everybody on the committee sort of put skin in the game, so to speak. So I'm presenting today. Nihad. You went live with me, Tom. Nihad, where are you, buddy? I thought you were doing a tutorial. And I went live without you. So you're supposed to be doing a tutorial. Hey, Joseph Ioli, good afternoon. So data centers, Willie Snyder in the house. Tech Tuesday is live and in charge. So busway is used heavily in data centers for flexibility. So we know we're going to be in Chapter 3. We know we're going to be in Chapter 3 wiring methods and materials. And I would argue busway is going to be one of those. Cable tray, I know cable management is critically important in data centers. So we're going to be navigating Chapter 3. And here's my thought process. I'm not going to just do this one and done. This isn't a one and done thing. I'm going to be looking for some data center experts, and we're going to dig into data centers on IAEI News Live. We're gonna dig into it week after week. Even if I have to record a session and play it, I am going to do what I can to get to the heart of data centers and try to understand the intricacies and requirements and maybe some gaps. We're going to do a gap analysis. I mean, the codes and standards isn't perfect, and there was a study done, and I want to share with you some words from a few areas. So, data center means busway and cable tray. It's lots of motor and cable tray, as well as lots of motor contribution. Absolutely. Jason, Nihad, yes, I meant without me. Just finished my tutorial and went back to your room. All right, so after this session, I'm going to pack up really quick, and you and I have to go over our PowerPoint. Cable trace is in 392. Shiati, what? Don, Ganir, Laurel is like my new research expert. I'm telling you. So chapter 4, we're into chapter 4 now. Chapter 4 for general use. Flexible cords and cables, probably going to see that in a data center. Fixture wires, well, we need lights. And why do we call it fixture wires? Didn't we get rid of fixture? Don't we call it luminaire? Should that be luminaire wires? Switches, we're going to have switches in data centers. Switches are great for isolating. Another big thing about data centers is reliability. I mean, sometimes I think we care more about our data than we do about our lives, and maybe data is our lives. I don't know. Switches is plays an important role. Obviously, receptacles, cord connectors, and attachment plugs. I mean, if you think about PDUs, if you think about a data center and you have a structure that has a PDU, you have multiple ways to plug in your computer technologies and things like that. We have switchboard, switchgear, and panel boards. You're definitely going to have probably. Now, here's another discussion point. And in my discussion today, earlier when I was advertising what we were going to be talking about today, Alan Bernstein sent a note saying he mentioned DC, which I was surprised, but he mentioned DC. So we're going to have to dig into DC in data centers. And he also mentioned medium voltage. The fact that they're bringing in medium voltage to these facilities and then distributing and because it's a lot of energy usage. Yummy Fudge brought that brought that to in the chat. And yeah, Felix, smash away, baby. Smash that like button. Hit it so hard you got to call IT to fix the computer. You know what I'm talking about. Come on. Cybersecurity. So, cybersecurity, Nihad and I are doing a balance of our goals and objectives, and security is one of those where cyber is very critically important in a data center. Very, absolutely right. Willie says, we did a data center and the new one was 1/3 the size of the old one. They're shrinking. Interesting. Here's the thing. Power consumption, power usage is critical. So artificial intelligence and any technology that can help the footprint, the energy footprint that AI brings to the table, because artificial intelligence is a power-intensive technology. But if there is new technology, I saw something announced, I think it was last month, coming out of China, that the Chinese have created an AI chip or something of that nature that's supposed to be less power draw. So we'll see where that goes. Yummy Fud switches, please. God, think of a better term in this context. Oh my gosh, you're absolutely right. Switches. Oh man. Let's go back. Where is that? It's Article 404. Those switches aren't the same switches you'll see in a data center. Oh my goodness. Emergency systems. Yes. So here's one of those areas, Felix, that I was thinking about. You raised the point of emergency systems. A data center. When I think of a data center, I could elect to categorize that data center as an Article 708 critical operation power system. And let's take a look at what the scope of Article 708 says. 708 says, and I should put this over here. Well, I am. I'm going to do it. I'm going to do it. Watch this. I'm moving it over here so that it's more comfortable for me. I'm right-handed. So this article applies to the installation, operation, monitoring, control, and maintenance of portions of the premises wiring system, which doesn't just mean it doesn't mean dwelling unit. Premises wiring system, it does not equal dwelling unit wiring system. Distribute and control electricity to designated critical operation areas in the event of disruption to elements of normal system. Critical operation power systems are those systems that are classified by municipal, state, federal, or other codes by any governmental agency having jurisdiction. And these systems include, but are not limited to, HVAC, fire alarm, security, communications, and signaling for designated critical operation areas. So somebody could say that a data center, if our data centers go down, just think, if Discover went down, Discover card, if their data centers went down, oh my gosh, I'd save money. I wouldn't be buying things. I might be able to afford my new car. Maybe get a new sport coat. Maybe it's not bad, but it could disrupt the economies globally. And Juan Carlos. So we're finally, I'm getting Facebook stuff. So my point here, Felix, was that you could classify a data center as a critical operation power system because of the fact that loss of that data system, loss of that data center could cause riots. It could cause people to take their lives because of their life savings or whatever. We rely on data systems. You would not be able to watch IAEI News Live. And I know for many of you, it's like caffeine. I mean, for anybody who just gets in there and takes a hold of an IAEI News session and starts chatting it up, it's like an addiction. right? I mean, you just can't live without it. So if data centers weren't up and I couldn't go live, oh my gosh, what am I going to do? So anyway, I agree with you, Felix. 115%. Juan Gonzalez, when we were talking earlier about temperature control for data centers, as far as 855 is concerned, are there any standards or protocols for capturing the heat dissipation to be reused for heating? Oh man, I don't know about that. Juan, that's a very good question. So what he brings up, so here's what he's bringing up. Let's just talk 30,000 foot view, 30,000 foot. What are the key things? I was going through the National Electrical Code just now, and I was looking at different articles. Now that's just the NEC. So you have electrical codes and standards that are going to play a role, obviously because it's an electrical installation. You have Article 645, we already mentioned. 708, Felix brought emergency systems up. So Article 708 is going to be critical. Article 250 for grounding and bonding, right? Article 240 for overcurrent protection. And now we've got all these medium voltage codes and standards articles that are being broken up and moved around and shifted and shaped and all that stuff in the National Electrical Code. All of those because we're going to have medium voltage applications as well. Section 110.26 for equipment space and being able to working space and whatnot. 701 and 702 optional standby systems, legally required standby systems. So in addition to Felix's point, I brought up Article 708. I went straight to 708, but 701 as a legally required standby system and 702 for an optional standby system, those are going to apply as well. That brings in transfer switches and all this stuff, which brings up standards. And we had Mr. Hofkin on the call, Michael Hofkin from Underwriters Laboratories. UL standards. There is an information technology equipment safety standard, UL 60950-1. How can I do this? Can I do this? Hold on. I'm going to put these UL standards. Copy. What can I put them in? I can put them on here. Watch this. New. And I'm going to change the paste. Here we go. I should be able to do this. All right, so here's some UL standards. We have UL 60950-1, 62368-1 for information technology equipment safety standard, covers safety requirements for IT equipment. You have 1008, that's your transfer switches. Anything that you're going to use in an Article 701, 708, Article 700, if it's transfer switch in those applications, you're going to need to have it as a UL 1008 application. 1778, UPSs, don't you think? Now, here's the question. Juan and Felix and Yummy Fudge and Dawn and anybody else out there, do we have an article on UPS systems? I don't believe there is an article on UPSs in the National Electrical Code. Correct me, please. What am I missing? I wish I had water. So 857 is busway. We already said busway. Now, busways applies to electrical busways used for power distribution in data centers. So 857 is a good one. What's the title? What's the title of 857? UL 857. UL 857. 857 is, we'll go to standards. Well, it just says busway. So the standard for busway. And we can dig in. We'll dig into busway eventually here. And I know somebody who asked me to do a program on busway. So that's going to happen as part of this series on data centers. 891 switchboards, so we know that. So those are some of the UL standards associated with data centers. Now, another thing to remember is that it's not just all about the electrical code and the UL standards around electrical equipment. We've got to think about fire protection and life safety. So now you have a few other NFPA key documents. NFPA 75 is the standard. Well, let's do this. I'm going to do the same thing. These are some of the NFPA standards. Oh, I'm hearing beeping and I'm not seeing things. I'm going to have to check my, hold on, I'm going to paste this and make it a little wider. My nose is itchy. And I'm going to show this. So what I'm going to throw up on the screen are the NFPA documents that I would say we have to rein in. I would also throw in there 70B, but this is just a sampling, right? So let me go back over here. Not emergency, but backup power, critical operations would only be for life safety. What about a data center for 911? What do you think about that, Willie? If you're relying on phone calls and you're relying on computers, you have a data center. And it's a 911 center. Do you think that way might be qualified for a 708? Maybe. How about the data center at the Pentagon for military operations? Do you think that might be a 708 system? If you're relying on a data center to fly drones in another country during a battle, do you think that you might be relying on that for life safety or for national security? Just maybe. I'm just throwing it out there. Don't shoot the messenger. David Engelhardt is in the house. Where is David Engelhardt? Felix Sandoval. Okay, Yummy Fudge. Hold on. Where am I? Hold on. Yummy Fudge. We had this separate power inverter. I really screwed this up. Okay, so that's that. Totally. What happens when Netflix, or Amazon Prime goes down? Oh, exactly. They do reuse the heat in data centers often. But good question on the requirements. Yes. Juan Gonzalez, just in case you forgot, Juan Gonzalez equals Mr. G. The 7-footer chopped in half of a Latino hillbilly whose thirst for knowledge far exceeds my limitations. Mr. G. I am now going to refer to you as Mr. G. I like it. UPS is energy storage system. No. Well, is a UPS an energy storage system? Here's what I would do. Here's what I would do. I would go over to the definition of an energy storage system, which I'm sure we have it defined. I am so sure. I would bet Yummy Fudge's next paycheck on energy storage. Yeah, see? You don't have to give your next paycheck away, Yummy. So I saved you one. You owe me. So, energy storage systems. One or more devices installed as a system capable of storing energy and providing electrical energy into the premises wiring system or an electric power production and distribution network. ESSs can include, but is not limited to, batteries, capacitors, kinetic energy devices. An ESS can include inverters and converters to change voltage levels to make change. Okay. Informational note number 2 says these systems differ from stationary standby battery installations where battery spends the majority of the time on continuous flow charge or in a high state charge in a readiness of dischargement. I don't see anything in there that it would lead me to say that it is not a UPS, but is it a UPS? Is that the area that I would follow for a UPS? I'm just going to do a search in the. Oh, there is a definition of a UPS. Whoa. Willie, if there's a definition of a UPS and there's a definition of an energy storage system, then they're not the same. All right, here we go. A UPS is a device or system that provides quality and continuity of AC power through the use of a stored energy device as the backup power source for a period of time when the normal power supply is incapable of performing acceptably. So, I don't believe we have an article on UPS. I would agree with you, Willie, that I could argue there's overlap. Do I go to my article on energy storage systems? Or do I go somewhere else? Don't tell me where to go. Hold on, let me do a search. In Article 100, let me go and look in the National Electrical Code for UPS. There's 645. Article 645 has a reference, and 645 is information technology equipment. Do I go to 645? Is that where I go? There are requirements in 645.11 that says a UPS systems installed within the information technology equipment room and their supply and output circuits have to comply with 645.10 except for the following. And what is 645.10? 645.10 says it needs a disconnecting means. So I think there's an opportunity. That's all I'm saying. Opportunity. All right. Boy, my nose is itchy. UPS is, okay, Article 480, stationary batteries. Yummy Fudge brings in stationary batteries, but that's not necessarily a UPS either, because we just saw in the definition of a UPS, it says it's not the stationary batteries. Stationary batteries just do trickle charges and stuff like that. Felix Sandoval. Saludos, hermano. I love it. ¿Cómo está? Eric Guadalupe. Glad you can make it. Look at this. We got, we're truly international. We are truly international. We are global. 645.11 mentioned UPSs. Yeah. Oh, yep. 645. There you go. Juan Gonzalez. Mr. G. Mr. G. UPS could fall under Article 480, stationary standby batteries. Yep. Oh. These systems are primarily intended to provide during normal operation conditions in the scope of 706. Let that article apply in the scope of 706. Let that article apply to a UPS. Yeah, 706. 706, I don't think 706 is it. That's your energy storage systems, and there's two defined terms. So I don't see that either, Dawn. I'm with you. I'm with you on this one. Okay. So let's go back. Now we sort of had a squirrel moment. We ended up back in the code. I was talking fire and life safety. 75, 76, 72, 70E, 101, life safety. Okay. Now how about mechanical and infrastructure standards? Somebody brought it up earlier. I can't remember who it was. It had to either be, Steve or tell Juan that I'm on YouTube, not Facebook. He's on YouTube. Yeah, you guys got to get over to YouTube. Yummy Fudge G, thanks. Steve, I think it was you that mentioned, I'm not sure who mentioned ASHRAE 90.4. Somebody mentioned 90.4 this morning. 90.4 is the energy standard for data centers. And we were talking about one of the biggest issues in a data center is dealing with the heat, right? And somebody mentioned Alan mentioned that we should put it over in Iceland, Greenland or whatever, where, it's like all you have to do is ventilate. But in any case, we have to address the mechanical and infrastructure standards. ASHRAE 90.4 is a good one. ASHRAE TC 9.9, thermal guidelines for data processing environments. So there's two ASHRAE standards. There's ISO 27001, information security management, ensures security measures to protect data and IT assets. And then there's TIA 942, that's the telecom industry, telecommunications infrastructure standard for data centers. So there's mechanical and infrastructure standards that we have to think about that are somewhat, I would say, electrical related. I mean, if I'm talking about energy efficiencies and things like that, and I'm talking energy, well, if I'm talking about heat, I'm going to need to probably cool or ventilate or whatever it is, right? Backup power and energy efficiency, IEEE 446, emergency and standby power systems. These are the best practices for backup power system reliability, 446. And then there's 3001.2, that's the recommended practice for evaluating the reliability of industrial and commercial power systems. This is your backup power. So IEEE 446, 3001.2, another one, IEEE Emerald Book for grounding and bonding. That's an electrical standard. I would throw that in the electrical codes and standards. That's more of an IEEE publication, but that's where we do all of our signaling and whatnot, your drain wires and things of that nature. What else? Eric Guadalupe. Hey, Eric, how are you? I think I've seen you recently. UPS can't consider ESS. NEC 708 and 855 define this as battery station system. So NFPA 855, another, so we can go to NFPA link. Let's take a look at 855. So I'll show you how we do this. What you do is well, here's what I do. I go back to home, and I might have it bookmarked. Do I have 855 bookmarked? Yes, I do. The 2023 edition. This is the standard for the installation of stationary energy storage systems. So 855, let's take a look at Chapter 1, Scope. This standard applies to the design, construction, installation, commissioning, operation, maintenance, and decommissioning of stationary energy storage systems, including mobile and portable ESS installed in a stationary situation and storage of lithium metal or lithium ion batteries. Now, why would that hit the table? Is because in the power distribution system for these data centers, they're worried about reliability. And if I have an outage, even if so here's the things we got to think about from a reliability perspective. If I have an outage, I can say I have a backup system. And the backup system is going to maintain power or make sure that I'm back up and running. The back up and running is the problem. So in your residential dwelling unit, for example, when you have a generator outside and you have a transfer switch and you lose power, I can... say you lose power, then the transfer switch says, uh-oh, we lost power. I got nothing coming from the utility. What does it do next? It starts the generator. Now, it still hasn't transferred from the utility, but it starts the generator, and the generator has to come up to speed. And then it says, all right, I'm going to transfer. And then, boom, it transfers over the loads that are being supplied from the transfer switch over to the generator. That takes time. You had a temporary outage. That's ungood in a data center. That's why the UPS philosophy, right? The fact that I don't want any loss of power. I need to have an immediate, as soon as power goes out, or not just power going out. If I have a transient voltage event that could disrupt my data, I need to address that as well. So those are all of the things that we need to think about when we're dealing with the backup systems for data centers. They can't take a temporary outage. All right? So Shall I continue? So Article 645 is going to be a critical one. Let's talk about, we talked about fire protection, we talked about mechanical, we talked about backup. Let me go back to this. Reread that first line of energy storage system. That describes a UPS and says does not apply. Oh, so you're saying the definition of the energy storage system. So go check that out. Thank you for that. Yummy. Dr. Ramoyu. Capabilities with facilities or utilities as a safe mode. I'm with you. Capabilities with facilities for utilities as a safe mode. I'm not sure where you're going with that one there. Eric Hammond in the house. Battery, stationary standby. Stationary standby battery, a battery that spends the majority of the time on continuous float charge or in a high state of charge in readiness for a discharge event. Now, where I typically have seen stationary standby batteries are in, I know when I worked at Crystal River Unit 3, we had very large battery rooms that basically, if we had an emergency situation and we had to safely shut down the reactor, we would run off of batteries. And we had I think it was an 8-hour profile. I think it was 8 hours. It was a 4 and an 8. I'm almost positive 8. I know 8 was in there. Was it 6 and 8 or 4 and 8? But we had two different scenarios, and we had to make sure that the battery load profiles were such that I did not drain the batteries, but I achieved my goal, which was to safely shut down the plant. Those batteries were there not for ongoing use, but only for that one emergency situation. Michael Hofkin says the basic standard used to investigate products in this category is UL 1778 UPSs. So Michael, we don't have an article for UPS. I'm not sure why we don't have an article for a UPS. I would have thought that it would be a chapter. I would have thought that I should be able to go to. Chapter 6, either 6 for special equipment, or I could argue that it's equipment for general use. I'd argue it's special equipment. I would think that it would have been in Chapter 6, but I do not believe, as I look down through Chapter 6, that we have anything in there for a UPS. I think we have a few sections peppered throughout, and we have it in 645 for IT equipment, but I don't know if it deserves its own article. I mean, UPSs are pretty complicated, and I've talked to a lot of inspectors about the nameplates on a UPS. How do you size conductors for the UPS? The nameplates are there's I think a lack of standardization on nameplates for UPSs. It can be challenging to determine the capabilities depending upon how many batteries are in there, what's installed. It's almost like an HVAC system, right? Michael, I don't know if what your opinion is. I'd value your opinion on whether or not we need a UPS article. Felix, all right, we've got international friendships going on. Thanks, guys. Freddie B, a UPS is an energy storage system, but not all energy storage systems are. Oops. There's a very educated statement. That's interesting. I like the way you put that. I'm almost buying what you're selling. UPSs should be considered at maximum capacity in HVAC calculations for data centers, regardless of what percentage they are actually used. Steve, amen. Because remember, one of the primary issues in and around data centers is going to be the heat that's generated, and it's interesting that the data center equipment, the power supplies, etc., will generate heat that will hurt themselves, right? So we have to protect these equipment from themselves. So getting heat out and managing the heat inside of a data center is a very critical piece of the puzzle. So very important to manage that. So then you have HVAC. So follow my logic here, Steve. When we talk about these cards, I think it's NVIDIA cards, they're heavily used for artificial intelligence, okay? And we say data centers, that those cards are heavy energy users. I'm wondering, and I'm not an expert in these AI, these NVIDIA. I have a computer with an NVIDIA card in it, but I'm not an expert. Just because I have one doesn't mean I'm an expert in it. I'm curious if it's because of heat. When we look at data centers and we say, boy, there's a large load here, is it because of all the computers? Or is it because of all the HVAC and ancillary equipment that's needed to cool that facility, room, area, whatever? Is it all of the ancillary loads that are the power consumers, or is it truly those racks of computers? I just find it hard to believe that a rack of computers would draw that many amps, but I could be 100% incorrect. I'm moving on. Juan Gonzalez with the Mr. G. With the usage of PoE systems being used in certain metropolitan cities, the recapturing of heat dissipation from data centers to be reused to heat PNFs eases the strain on the depletion of fossil fuel energy sources, bringing about reduction in environmental pollution levels. Hence, 855 becomes an item of interest. Very good point. Very good point. Steve says yes, 90.4. Freddie B, energy storage systems. Informational note number 2. These systems differ from a stationary. Exactly. Yummy. That's not an energy storage system. Where battery spends the majority of the time on continuous flow charge. And that's your 4. What is that? It's a standard where's batteries? 460. Oh man, what were your batteries? Man, what was this section? I thought it was chapter 4. Is it chapter 6? Is battery systems chapter 6? Where's the batteries? I thought batteries was chapter 4. 4 something. Phase converters, resistors, stationary batteries, 480. Article 4. Boy, Article 480. I thought it was chapter 4. Eric was mentioning 706. Fred, I noticed that in the definition. Yep. So we're learning together. I love this. It's critical to have temperature, humidity control for the electrical equipment in data centers, which suffer if overlooked because the focus was the IT, information technology, yes. So, Nihad and I are doing a paper, or we're going to deliver a paper today at 2:30, I think it is. And we're talking about the trade-offs in design goals. Safety is in there. It's one of those. And we have compromises. We always compromise on something. No matter what it is, you're going to compromise, right? Because sometimes it's financially driven, sometimes it's safety driven. You may, for example, get on a motorcycle and decide that, hey, I have to put a helmet on, so I'm compromising my hairdo, right? And I know I spend a lot of time on my hair. I have to make sure that it's groomed just right, and then I put a motorcycle helmet on or a hard hat, right? I'm compromising my looks, which aren't much to begin with. But in any case, you have to be able to balance all of the goals and objectives for a data center. and temperature is a critical factor. And somebody mentioned that DC distribution could alleviate that. Oh, and I'm going to bring that up here before we get off this call. That perfectly describes a UPS, which states all the. Yep, so we're in that in number 2 to the definition. Energy storage system strongly suggests that Article 480 applies to a UPS. Ooh, that's news. Energy storage, you said in informational note number 2, energy storage system. It says these systems differ from a stationary standby battery installation where a battery spends the majority of the time on continuous flow charge or in a high state of charge. And oh man, yeah. I see what you're saying, Dawn. But it doesn't, yeah. You know what this is, Dawn? Opportunities. Donnie Cook used to tell me, and he still does, Thomas, there's opportunities all around us. Just got to know when to pounce and when to walk away. So, yes, sir. Opportunities. Eric, excellent point, my brother. I was thinking that recapturing dissipated heat to be rerouted to be used as an alternative heating source might fall under NFPA 855. Excellent. Jason, 700.12e states that a UPS is considered a stored energy power supply system. Yeah, I saw that one too, Jason. You gotta love this stuff. Those data centers are a full rack, of which there are hundreds, can cost over millions of dollars each, times up hundreds. You could almost imagine a new special location section in the code for yes. You're absolutely right, Steve. I think that an article that covers data centers would be interesting. Now, you might say, well, information technology covers that and you should just rename that. I don't know. But that's what I'm thinking. I hate to say, I think a true data center, not an office closet or a room with 5 racks, but a full data center may benefit from a separate publication. Oh, that made you know it. Here's the thing, Yummy. It just might be a good idea when everybody walks away from the table wanting to just throw up on what they just did. So it might be a good idea. How do I switch over to the YouTube platform? Just open up another window, baby. Just open another window. But I'm getting you. I'm getting you on Facebook. Come on. Don Gannier, there is an article 646 and a product standard for modular. Oh, yeah. That's the other standard. So now you have the fact that we can take a data center, put it in a box, put it on wheels, and take it anywhere we want to take it. What are the codes and standards for that thing? Is that a listed enclosure? Michael Hofkin, do you guys walk around listing trailers that have data centers in them, and what would you list them to? Do we do that? Do we not do that? Does an inspector have to go inside that trailer and inspect to the 646 standard or article? I'm telling you, opportunities are all around us. 645.11 refers to 685. 645.11. 645.11. I think I recall Yeah, Article 6, installations complying with parts 1 and 2. So UPS systems installed within the information technology equipment room, and it does point to 685 for integrated electrical systems. And man, there's so much. Yes, computers dump heat. We have not used CPUs for the actual computer for years. It's all GPUs. Yes. Yeah. Based on graphics cards. And, okay, so they use a lot of energy per rack. So in addition to the HVAC and the balance of everything else that we're doing, these GPUs do love. They eat, drink, and sleep energy on a daily basis, and they never gain weight and get fat. Juan, Thomas, their data centers may be cooled with a system of nitrogen. Oh, to increase the heat. That's interesting. I didn't think of that one. Mr. G. Yep, I saw that. Freddie B, 685 reference you all over the place. 685.3. Is that right? 685.3? That's your integrated facility, integrated electrical systems. 685.3 is applications. Oh, yeah. Oh, yeah. Look at that. Look at this. 685.3, application. Application of other articles. The article sections in Table 6A apply to particular cases of installation, conductors, and equipment where there are orderly shutdown requirements. So you got ground fault protection of equipment, 230.95, 240, 250. It puts you all over the place. I love it. Can't get better than this, Fred. Uh-oh, squirrel moment. My avatar picture was hand-drawn for me while I was in the basic training. It's a picture of me getting hit by a rock and a drill instructor off to the side of the screen. Oh my gosh. Only you. Only you. The power comparison you were talking about for the IT versus support like HVAC, known as PUE, power usage effectiveness. Oh, I would love that, Steve. I would love to have that. Please share away, brother. Thank you. Don't forget, like and subscribe. Make it happen. Don't forget. Oh, man. Holy cow, we've got some good dialogue here. The problem is not what to do with the heat, but how to cool them in the least amount of energy. Yeah, you're absolutely right. Tom Lichtenstein on modular. Yes. Oh, last Friday. He did one, I think, at the Western section, too. To date, you has not listed any MDC, even though such listing is required by 646.4. Oh, the webs we weave. Yeah. I love it. I love it. You don't read the rest of my comment above about special location data center regarding the rapid heat rise environment and cascading failure of HVAC dropouts. I didn't see the rest of it, Steve. Oh, wait, maybe, is this one? Power compare. I can send you a link. Yeah, I wasn't, I don't know if it's getting cut off on me or I just didn't read it. Wow, man, I'm telling you what, you guys are chatty caddies today. Where's it at? Where was I? Eric, greetings, my brother. I haven't forgotten about you. I owe you a follow-up on the transformer topic. Man, you didn't read. Here it is. You didn't read the rest of my comment above about special location data center regarding the rapid heat rise environment and cascading failure if HVAC drops out. I got the comparison. I'm looking. Juan Carlos. Yummy. Juan. Geez, Steve. Yeah, I didn't see it. I'm not sure where it's at. Sorry, Steve. I apologize, brother, from another mother. All right, Juan says, oh, we saw that one. Don Ganir. Outline. Oh, UL 2755. Modular data centers. I got to write that one down. I don't believe I have that in my list. UL. Dun, 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 dun. Return. UL. What is it? 2755. Write that down, gentlemen, ladies. Eric Guadalupe, 2020 NEC 645. Yep, address certain requirements for UPSs installed for use with information technology. I'm with you 100%. So it seems like they pepper things throughout the code. It would be very attractive. 685. 685, I don't believe that's in there. IFC and IBC identify that UPS installed shall be installed, inspected, tested, and maintained in accordance with NEC and NFPA. So there's a tie between the ICC and the code. That's good to know. What about reactive requirements of a day? Oh my God, it's 101. All right, so I didn't get to. Oh, he says he does. Michael Hofkin says they do list modular data centers. Hey, Tom, I have to run downstairs. They were looking. Oh, boy. All right, Nihad. And it is 101. Ladies and gentlemen, I have to go on stage. My squirrel moment is over. Thank you for watching. Thanks for what you do. We are going to do a series on data centers. Send me all your materials. Give me information. Let me know. We're going to talk DC distribution in data centers as well. That will not go unchecked. We will do that. We're going to talk about the energy profiles, energy usage, and if you know some data center gurus out there that would love to go live with me on IAEI News Live, let's make it happen together. All right? I've got to run. I got to get on stage. Take care, stay safe, and please stay healthy.